I am Anil Kumar. Welcome to my YouTube channel. In this video, we'll discuss properties of rhombus. I'll list most of the properties based on the angles which are formed inside and the length of the sides and diagonals. And then we have two problems for you. One, where we are going to calculate the angles, and the other one, where the lengths will be considered. So let's begin with the properties of the rhombus. Rhombus given to us is rhombus ABCD. So I'm putting the symbol for the rhombus ABCD. ABCD, as you can see, are the vertices of this particular rhombus. Rhombus is a quadrilateral in which all the sides are equal. So AB is equals to BC is equals to CD, which is same as DA, right? So it is a quadrilateral where the sides AB, BC, CD, and DA are all equal, right? So that's the first part. And then we also have the diagonals. Well, the diagonals of the rhombus are not equal, right? So remember one thing, the diagonals are not equal. So we know that AC is not equal to BD. Now, square is a very special rhombus in which the diagonals are also equal, but in general, the rhombus diagonals are not the same. However, the diagonals do intersect at a point and they bisect each other. So each half of the diagonal is equal. So the here, as you can see, A to O is equal to O to C. So AO is equal to OC, and also B to O is equal to OD. These diagonals also intersect at right angles, so they intersect and they are right bisectors of one another, as you can see in this particular figure. The figure is not to the scale, however, it gives you an idea. So, as far as the lengths are concerned, I hope you got good idea that all sides are equal length, diagonals are not, diagonals do bisect one another. Now, let's look into the angles. Let's begin with angle 1. Now, angle 1 is equal to which other angles? Can you tell me that? Well, angle 1 is equal to angle 2 is also equal to angle 5 and angle 6. So, in rhombus, the diagonal actually bisects the angles at two ends, and the angles at the opposite corners of a diagonal are always equal. So this angle A, which is angle BAD, is equal to angle BCD. So angle A is equal to angle C, and also the diagonal, it cuts into all equal angles. So angle 1 is equal to 2 and is same as 5 and 6. Similarly, we have the other angles which are angle 3, 4. They are equal to angle 8 and angle 7. And of course, these two angles are also equal, right? So you see the angles, opposite angles are equal in a rhombus. Now, one more important thing here is that the adjacent angle sum is 180. That is to say that the angle ABC plus angle BCD is equal to 180 degrees, and it is also equal to angle A, we can say BAD plus angle ADC. So sum of adjacent angles is 180 degrees. So there's so many properties which we can see for a rhombus right there. Perfect. Now, based on these properties, let's have a question on angles itself, which is we are given a rhombus. And when we are given a rhombus, we know that the opposite sides are parallel, right? And also all the four sides are equal. Now, in this case, we are given an angle of 116 degrees. Can you tell me what is the measure of angle x, y, and z? Right? X, y, and z. So we are given one angle as 116. Let's label it as the sides A, B, C, and D, right? Now we are given that the angle ADC is equal to 116 degrees. Now, since ADC is 116 degrees, ABC should also be 116 degrees, right? So that should be equal to angle ABC, right? Is equal to angle ADC, right? So both are 116 degrees. So we got Y as equal to 116 degrees. Makes sense. These are the opposite angles of a rhombus. How about the other two? Well, we know that the sum of these two, which is, I should say, angle ABC plus angle BCD, is equal to 180 degrees. And we also know that Z and X should be equal because the diagonals bisect one another, right? So that is one part. So we also know that angle, I should say, X is equal to Z, right? Since the diagonal bisects it. Correct. So that means that the angle BCD is can be written as 2x, right? Which is x plus z. So now we can plug in the values. We know 116 plus 2x is equal to 180 degrees. And we can now find what is x equals to, right? So 180 minus 116, which is 4, and 10, 8, 7 minus 1 is 6. So 2x is 64, x will be 64 by 2, which is 32 degrees. So we get the angle x as 32 degrees. And since z and x both are equal, both should be 32 degrees. So we get our answer, which is y is equal to 116 degrees and x is equal to z, which is 32 degrees. So I hope that is absolutely clear, right? Now let's take another example, which is based on the lengths of the diagonals. So again, let me label this rhombus as ABCD intersecting at O. We are given that AO is equal to 2x plus 2, and we are given that BO, which is equal to OD, and the sides are 2x minus 1, and that should be equal to 4x minus 7. Since these two sides are equal, we know they intersect at right angles and they divide one another equally. They are right bisectors. Simplifying this equation, we can actually solve for x. Bringing 7 to this side, we get 7 minus 1 equals to 4x minus 2x, 6 equals to 2x, or 6 by 2 is x, which is 3. So we know x is 3, right? Since x is 3, we can find the length of each diagonal, right? So that gives us the value of x. Now, so 2x minus 1 will be equal to what? 2x minus 1 will be 2 times 3 minus 1, which is 6 minus 1, which is 5. So I can write down this side as 5. The other one will also be 5, correct? How about the side 2x plus 2? 2x plus 2 will be equal to 2 times 5. Sorry, x is 3, right? So 2 times 3 plus 2, which is 2 times 3, 6 plus 2, 8, right? So this is 8. The other one has to be 8 for us, right? Correct. We need to find what is B to C. Since we need to determine length of each diagonal and the perimeter of the rhombus. So length of each diagonal is easy to find. We can now say what is length of diagonal B to D, right? So BD is equal to twice BO, right? So BD, as we said, was 5 plus 5, 10. The other one, AC, is 8 plus 8, which is 16. So these lengths are known to us. Now, to find each side of the rhombus, we know that the diagonals intersect at right angles, the two sides being 5 and 8. So the hypotenuse should be what? So BC square equals to 5 square plus 8 square, which is 25 plus 64. And so BC is square root of 25 plus 64, right? So which is square root of 89. So that becomes the value of BC, which is one side of a rhombus. Since all sides are equal, we can say that the perimeter is what? Perimeter is 4 times square root of 89, right? So that is how we can actually find the perimeter of this rhombus also. So I hope that makes sense. With that, we have found the perimeter along with the diagonals of the rhombus. Of course, the figure is not to the scale, but I hope you have understood how do we solve problems related to rhombus from the basic properties. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.